Hello and welcome to the video on understanding the basic concepts of electricity, such as volt, ampere, watt, and ohm, using a simple syringe model. Have you ever wondered why some appliances constantly drain your wallet? To use electrical energy efficiently and keep your electricity bills in check, it's important to understand the key players in the world of electricity. Imagine a syringe filled with a fluid. The force or pressure you apply to the plunger acts as the voltage. The harder you push, the greater the pressure, and the faster the fluid flows through the syringe. Similarly, in an electrical circuit, voltage acts like the electrical pressure that pushes electric charges through a conductor. The higher the voltage, the stronger the push and the higher the flow of charges. Voltage is the electrical energy supplied by a source per unit of charge. A source that supplies 1 unit of energy to each unit of charge is 1 volt. A voltage of 230 volts indicates 230 units of energy per unit of charge. Common household outlets typically provide around 230 volts in many countries. The flow of charges through a wire is called electric current. It is similar to the flow rate of a fluid through a pipe or opening. It is measured in amperes. If 1 unit of charge passes through a device in 1 second, we call it 1 ampere. Common household circuits are rated at 15 to 20 amperes. The flow of a fluid through a pipe depends on the pressure and the size of the pipe. Similarly, electric current depends on the applied voltage and the size of the conductor. Opposition offered by a material to the flow of electricity is called resistance. It is measured in ohms. The resistance of a conductor is similar to the size of a pipe. A thick conductor is like a wider opening, offering less resistance and allows more amperes to pass. In contrast, a thin conductor is like a narrow opening, offering more resistance and restricting the flow of current. A material that requires 1 volt to allow 1 ampere of current has a resistance of 1 ohm. A material that requires more voltage to allow 1 ampere of current has a high value of resistance. The higher the resistance, the less current will flow through the material. The energy of a moving fluid can be converted to other forms of energy, such as turning a wheel. Similarly, electrical energy can be converted to many different forms, like light, heat, or motion. The amount of work done by a fluid in 1 second is called its power. It depends on the pressure and the size of the opening. The higher the pressure or wider the opening, the greater the power. Similarly, the power of an electrical device depends on both the applied voltage and the amount of current that flows through it. It is measured in watts. A device that consumes 1 unit of energy in 1 second has a power of 1 watt. A device that consumes more units of energy in 1 second has a higher power rating. For example, an iron consumes 1000 watts, which indicates 1000 units of energy consumed by the device in 1 second. Both voltage and wattage represent electrical energy, but they play different roles. Voltage is related to the source that provides electrical energy to each coulomb of charge, while the wattage is related to the device that consumes the electrical energy each second. Your electricity bill is based on the total energy consumption, measured in kilowatt-hours. 1 kilowatt-hour is equal to 1000 watt-hours. So, a device that consumes 1000 watts, for 1 hour, will use 1 kilowatt-hour of energy or 1 unit of electricity in your bill. Knowing the wattage of your appliances and their usage time can help you estimate your electricity consumption. The major contributor to electricity consumption in the average home is the heating and cooling equipment. Consider an iron and a light bulb connected to the same source. The iron has lower resistance than the light bulb, so it allows more charges to flow each second, consuming more energy. This is why an iron typically consumes 1000 watts of power, while a light bulb only consumes 15 watts. Understanding volt, watt, ohm, and ampere is key to making informed decisions when selecting appliances for your home. By remembering the syringe analogy, you can easily grasp how these concepts interact and influence energy consumption in your home. I hope this explanation helps you understand more about electric current, resistance, voltage, and wattage. For related videos, click the I button, or follow the links in the description. Thank you for watching.